Hello everyone, I am Dr. Saurabh Saxena. I am working as Associate Professor in Applied Science and Humanities Department at ABES Engineering College, Ghaziabad. The topic for today's discussion is Laplace transform of unit step function. But before moving towards the Laplace transform of the function, first we'll understand the definition mathematical approach for unit step function. So let's start. What is unit step function? The unit step function is defined as ut minus a is equals to, its value is either 0 or 1. Its value is 0 when t is smaller than a, and its value is 1 when t is greater than or equals to a. In such a mathematical form, the unit step function is defined. If in particular case, if a equals to 0, then ut is defined as, again, its value will be 0 or 1 if t is greater than smaller than 0 and t is greater than equals to 0. So this is the basic definition of unit step function. Now we are moving towards the Laplace transform of this function. So Laplace transform of unit step function. We all know that Laplace transform of any function ft may be defined as the mathematical approach. Laplace transform of ft is defined as integral 0 to infinity e to the power minus st ft dt. Here our function is unit step function. So in the place of ft, we will be putting u t minus a. Now for unit step function, we get Laplace transform of ut minus a is equals to integral 0 to infinity e to the power minus st, and the function is ut minus a dt. Right? So we have to evaluate this integral e to the power minus st ut minus a dt. But we all know that ut minus a is the unit step function, so its value is defined in two intervals. The one is when the value of t is smaller than a, and when the value of t is greater than equals to a. So we'll break the limits 0 to infinity in two parts. The one is 0 to a and the other is a to infinity. So we'll be getting Laplace transform of ut minus a is equals to integral 0 to a e to the power minus st ut minus a dt plus a to infinity e to the power minus st ut minus a dt. And as mentioned earlier, the value of unit step function is 0 when t is smaller than a. So in the interval 0 to a, t will be smaller than a. So we will be putting the value of the unit step function as 0 in the first integral and 1 in the second integral. It is equals to, this first integral will be 0 plus, we are left with the integral of e to the power minus st dt. So integral of this function e to the power minus st will remain like this, and minus in the division, and the limit it goes to like a to infinity. Imposing the limit 1 upon minus s, keeping outside, When we'll try to impose the upper limit, we'll be getting e to the power minus st when t approaches to infinity, and e to the power minus as. Directly we replaced t by a. So we'll be getting, we know e to the power negative infinity approaches to 0. So it will be minus 1 by s outside. It will be 0 minus e to the power minus as. And finally, we can get Laplace transform of u t minus a is equals to 1 upon s e to the power minus as. So this is the Laplace transform of unit step function. Now, this is not the only problem that will be asked in your examinations and in the competitive uh, examinations. There might be other way out in which the problem may be asked. So we'll be going forward and we'll find out the Laplace transform when the unit step function is multiplied by some other function. So in the Q, we are going to find out what will be the Laplace transform of the function of the form ft minus a ut minus a. This particular concept may also be termed as the Laplace transform for second shifting theorem. We understood this concept by second shifting theorem. So let's start how to evaluate the Laplace transform of this function. Again, we'll be going through by the basic definition. So Laplace transform of this function may be written as 0 to infinity e to the power minus st f t minus a u t minus a dt is equals to, again, here again the function ut minus a is written and unit step function is defined in two intervals. So we'll again break the limits of the integral in two parts. The one will be from 0 to a e to the power minus st f t minus a, and the value of ut minus a in the interval 0 to a will be 0 plus integral a to infinity e to the power minus st f t minus a. The value will be 1 in this interval, and we'll be getting integral a to infinity e to the power minus st f t minus a dt. Now integral is to be done with respect to t. So what we do, let t minus a equals to u. We have taken new variable u as t minus a. So this implies dt may be replaced directly by du, and the Laplace transform of ft minus a ut minus a may be given as integral e to the power minus s. T may be replaced by a plus u. Ft may be t minus a. So here t minus a will be replaced by fu, and dt will be replaced by du. Now think about the limits. Here the limits were of t. So when t will be a, u will be, when t will be a, u will be a minus a, that is 0. And when t will be infinity, u will be infinity minus something, that is infinity. So you have got the expression like this. Since the integral is being done with respect to u, we can take minus as power of exponential outside. So e to the power minus as may be taken outside. Integral 0 to infinity e to the power minus au fu du. Okay, and now what about this? This is the basic definition of Laplace transform. See, this was the basic definition of Laplace transform. Laplace ft is equals to 0 to infinity e to the power minus st ft dt. Just in a similar way, here it is being written 0 to infinity minus au fu du. So we know that in case of definite integral, the name of the variable is not a matter for us. So what we can write, it is e to the power minus as Laplace of f t. So this is the Laplace transform of f t minus a u t minus a. Whenever we'll come across the expression like ft minus a ut minus a, its Laplace transform may be given as this only. Laplace of ft minus a ut minus a is equals to e to the power minus as Laplace of ft, or we can also write it as e to the power minus as f of s. So this is the Laplace transform of ft minus a ut minus a. Now, many a time we come across the situations where the function is not in the form of ft minus a. That is, we have to find out the Laplace transform of ft ut minus a. So the Laplace transform may be obtained in a same way. It may be written as integral 0 to infinity e to the power minus st ft ut minus a dt. It will be equals to 0 to a e to the power minus st ft, and the value of ut minus a in this interval will be 0 plus a to infinity e to the power minus st ft, and the value of ut minus a in this interval will be 1. So we are left with only a to infinity e to the power minus st ft dt. The expression is just same as of the Laplace transform of ft, but the only problem is about the limits. Limit is given from a to infinity, whereas in the basic definition of Laplace transform, the limit was 0 to infinity. So to convert this limit, again we will be doing the same job, that is, let u is equals to t minus a. It implies du equals to dt or dt equals to du. So the Laplace transform of ft ut minus a is equals to e to the power minus t will be replaced by u plus a, and ft will be replaced by f u plus a du, and limit will be converted to, when the value of t will be a, u will be 0, and the value of, when the value of t will be infinity, u will be infinity. So we can do like this. E to the power minus as may be taken outside. Integral 0 to infinity e to the power minus su f of u plus a du. Or we can write in the more familiar terms like e to the power minus as 0 to infinity e to the power minus st f t plus a dt, because we know indefinite integral name of the variable may be changed. So in this way, finally we get e to the power minus as Laplace transform of, now the function is not only ft, it is f of t plus a. So this is the Laplace transform of ft into u t minus a. So we have gone through three basic transforms. The number one, Laplace transform of u t minus a is equals to 1 upon s e raised to the power minus s. Number two, Laplace transform of the function f of t minus a ut minus a is equals to e to the power minus as Laplace transform of ft, or e to the power minus as Laplace transform of ft may also be termed as fs. And the third one is Laplace transform of ft ut minus a. If the function is given in terms of ft, not ft minus a, then in this case, Laplace transform is given as e to the power minus as Laplace transform of f of t plus a. So these are the three basic Laplace transforms of the function related to unit step function. In the next video, we'll go through various problems that are based on unit step function in which they are asked in your various examinations. So these are the references. Thank you very much.